the hell do we always use aluminum for Diana headphones?
Nobody knows. It's a big mystery.
Yeah.
There's
Why
a-
not titanium?
Titanium.
We actually did think about that at one
Yeah,
point.
there's a lot of reasons for that one.
Yeah, right. Well, there's a little steel in there too, though.
Oh, there's a little bit.
Yeah.
Well, yeah. Okay. We need steel to concentrate the magnetic field.
Yeah.
Otherwise, the flux capacitor won't work.
Flux
Stop
capacitor.
fluxing.
Yes. And then the headphone can't take you back in time to when the recording was made.
Hmm.
Yeah, see, that people don't even know about that.
Oh
one.
yeah.
Yeah,
No,
there is-
they don't.
They don't realize there is a flux
A
capacitor.
little known fact.
Mm-hmm.
And there you go. Now you know our secret. Patent pending.
So Diana, it's supposed to be a thin and light. So why would you make it out of metal? You can make it out of plastic or some sort of lightweight thing, right? Because metal, ooh, that's so heavy. And it actually, this is kind of heavy.
Yeah.
That's heavy, yeah.
Quite.
The half machined side of a Diana.
Well, I would
What's
call
that,
it less
probably
than
about 2
half.
pounds?
It's less than half. Yeah.
Yeah, probably about a kilogram of aluminum, a block.
It's considerable.
That one side of Diana's machined out of. I think we remove like 95% of the material to create the shell.
It's like 94. Yeah,
94.
It's a lot.
Yeah. So what's left is 6% of what was a block of aluminum.
Something like that, yeah.
Mm.
Don't worry, we recycle that, but yeah.
What that results in is a product that is comparatively very rigid, very strong and durable, and rather lightweight as well. So compared to that being out of like an injection molded plastic part, you wouldn't really be able to design it like that.
Yeah. No.
You wouldn't be able to get the strength out of it feasibly to make that type of part work well.
Yeah, it would have to be thicker plastic.
Yeah.
Yeah.
And if you were to make it look like that but function in a plastic part, it would most likely weigh more. It depends on how you design it because you couldn't really make it exactly like that. But generally speaking, that's actually a lighter part than a plastic part.
Not only that, it would sound like plastic. And I know that's a difficult topic for people to understand, but materials have a sound, a characteristic sound when you're playing music within them. It's kind of like putting like a shell out of the ocean against your ear, and I hear a noise coming from the shell. I mean, that's kind of the airflow through the shell, but the shell creates its own noise,
Well, yeah.
right? Yeah, I mean,
Kind of.
Yeah.
so, but if that shell was made of plastic, it wouldn't sound the same as a shell that came out of the ocean, for sure.
Oh, 3D printed shells.
Or if it was made of concrete, it certainly would sound different too.
Well, that is true. We do have some plastic Dianas though,
Yeah,
and yeah, they are a little lighter.
yeah,
But wow, are they weak?
yeah.
You know?
What, the 3D printed
Yeah,
one?
yeah.
Well, yeah, they're very weak because
Yeah,
they're literally printed to geometry. So
Right.
Yeah, and we've
Yeah.
done some 3D printed closed-back prototypes too, and
yeah.
they sound severely like 3D printed plastic.
They sure do.
And it's because it's not going to close back with nothing in it. So all you're hearing is the reflections off the plastic from the driver, and it sounds like sound reflecting off of plastic. And that's the reality of materials in such an enclosed, particularly in such an enclosed space. Speakers run into this too, where their cabinets, the interior of the cabinets, most speaker manufacturers line their cabinets with foam. Well, a majority of that is so that you don't hear the sound bouncing off the wood in the cabinet, coming through the cone materials of the driver, and you hear the interior of the cabinet. You're trying to dampen those interior vibrations and resonances from getting back through to the sound and mucking up the signal coming off the actual driver. And it's the same in a headphone. You really want to not hear the materials. You want to hear, assuming the driver sounds good. There are a couple speaker manufacturers that actually want the cabinet to resonate because the cabinet resonating adds color
Yeah.
to the sound.
So I guess the most extreme in the other direction would be like Magico, and to the lengths they go with their cabinets to be as nerd
Crazy.
as possible.
Crazy.
Like their baffles on their sub is like 2-inch thick aluminum
Can
and
you
stuff.
imagine that? The
And
weight
they're
of
like,
that?
it still
Wow.
flexes a little bit, but
Yeah.
That's impractical for a
Yeah.
headphone.
Yeah.
Oh,
a
2-inch
bit.
thick?
Yeah.
Yeah.
But this part,
We could do it,
2-inch thick headphone.
but you'd need a support structure to wear it.
Oh,
yeah.
yeah.
That probably goes on your shoulders and stuff to be able to handle the 50-pound
You'd
weight.
be making speakers
Yeah.
that are
That's
on
true.
I don't know. I think the returns on that one aren't stellar.
I think it'd be a bad idea.
You're a little past
People thought
diminishing
the
returns.
Jacqueline float was a bad looking thing.
Yeah. giant
Just big bricks. Yeah.
springs hanging
That
from
rest
the
on your
ceiling.
shoulders with shoulder pads. Oh, that'd be something. Yeah, at that point, you're better off just getting a big boom. Remember the boom boxes they used to have? People carry them on their shoulders? That's where you want to go with that.
I suppose.
Yeah, that's a different thing.
Well, get one that works on a car battery with a lot of power. Then you're good. Small car battery. Okay, we'll go for
Yeah, that's old school. Yeah, you want to be running a
12
12
volts. Yeah, you put a car radio in a pine box with
Yeah.
two big
Yep.
6x9s.
That's how they
Oh,
did
yeah.
it back in
Crank
the day. I
the
bet.
shit out of it. Yeah, it's good for outdoor use.
Mm.
You need power. Anyway, what
There's
were we talking
options these days.
about? Yeah.
So, personally, I find a machined aluminum enclosure to be a very viable choice. And a bunch of other manufacturers settle on this as well, so can't be too far off. But it offers very high rigidity, good strength, which they are two different things. And aluminum is comparatively low cost for a machining process. The material isn't super expensive or rare, but it results in a very durable, reliable, robust part. You can hold tight tolerances. You don't need to worry about humidity and whatnot, and temperature changes causing dimensional issues.
The expensive tooling on our CNC machines lasts a good time because
True.
to the bits and the tools in the
Yeah.
machine, it cuts through aluminum fairly
Aluminum's
easily.
easy to machine.
It's almost
so,
like
yeah.
butter to a knife
Because you
much.
could make it out of a different metal. Of course, there's a whole bunch of different exotic alloys.
or
that
wood.
You can make it out of wood, but you couldn't make that part out of wood. It'd be very, very brittle. Even if you used a real fancy, hard, stabilized wood, it would need to be a very different design.
Well, they need like inserts for the screws and stuff.
Right.
Adding more weight.
And tolerances would probably suck.
Well,
Well, I
depend on
suppose that's
humidity.
something a lot of consumers probably aren't aware, but generally speaking, most products are designed around the manufacturing process and the materials they're going to be made out of.
Kind of have to be.
Well, if they're optimized.
Yeah.
So if you make something in plastic and you just change it to a different material and you make it exactly the same, usually there's huge optimizations left over for cost, weight, size, reliability, whatnot. But if you heavily optimize it for one particular material, you can't just change materials. It's a different product, different manufacturing thing. And to make something like this out of titanium, it would be much, much heavier. It'd be very, very difficult to machine. It would be orders of magnitude more expensive. It would be astronomical.
And it would serve no
raise in
real
And it would
purpose.
serve
Yeah.
absolutely no function.
Yeah.
No functional enhancement other than
Yeah.
you could do like a cool flame anodize or something
Right.
like that on it, which is pretty sick.
We looked
Yeah.
into that, but it's rather random.
Yeah. Well, I want to do like a PVD or something like that. Do like a rainbow PVD coating or something. Or do some fancy pants coatings on that. But you could do that on aluminum, and then that's much more practical and economical. Making that out of titanium would be insanity and provide absolutely no functionality. And in fact, it would be considerably heavier.
So I guess what it boils down to make a shape like that into a headphone, there's not a hell of a lot of other materials to choose from.
Well, they all got their pros and cons. I mean, you can make it out of magnesium and it'll be lighter, but then it's got different problems
It's
like
too expensive.
price and fire.
Yeah. Isn't that the shavings from that kind of burn?
Yes, it's potentially problematic in that sense. There's a risk
Explosive or
of
yeah.
potential
It's dangerous
fire
stuff
and
to work
explosions.
with
Yeah,
in a
aluminum
machine
is
setting.
stable.
And on top
Yeah,
of that,
but-
the
Yeah.
cost of magnesium is so far off aluminum, the difficulty to maintain, to get it and stuff like that in bars and whatnot. It would be a supply nightmare, especially during this current
Well, but yeah,
situation.
availability is a big one too.
But
true.
aluminum,
Yeah.
huge supply network, very economical raw material. Really, what you pay for in a machined aluminum part isn't the material; it's the time put into the part. The material is a few bucks or whatever.
It's the machine time.
The machine time is potentially very, very expensive.
Yeah.
But
Well, the machines are expensive. The tooling's expensive. The guy running the machine is expensive.
yes,
The guy programming the machine is expensive. So people probably don't understand there's a whole ecosystem around a machine. It's not just a machine making parts. It
No,
doesn't
it's a big
happen by
network.
magic. There's
Yeah.
a lot of steps that come before the machine can actually make the part. A lot of steps that go on while the part's being made, and then there's a lot of steps after the part's made. So
Yes.
so that's where the time comes in. It's a lot of time to make
It's a lot.
parts
Yeah.
on a CNC machine.
and it's not $2. The machines are expensive. They're expensive per hour to operate.
Right.
There's hard costs, electric costs. These things are not trivial. They're really substantial costs.
Yeah.
I mean, there are logistical reasons too of running all aluminum because then all the machines are all running the same tooling. You can interchange stuff as you need it, and they're all running aluminum, so you don't need to like clean them out.
Right.
Switching materials and such. So it's
Yeah, it
easier.
makes a mess of things if you start
Yeah.
throwing wood chips into
Yeah,
a CNC running aluminum.
which we did do once.
You make a
I
spit
would
of a
recommend it.
slurry going on there
Yeah.
in the coolant.
Yeah, 5 different chips in there. Then you
Yeah.
can't really effectively recycle them.
Yeah, the
Nobody wants your
recycling,
Yeah,
chips.
right. Yeah, it's called garbage.
Yeah,
Yeah.
contaminated chips.
Yeah, so so that's another point is mixing and matching. Like if we run a steel part, we'll run the steel onto one machine and you got to clean it out.
Yeah, it's like an hour
Yeah.
to clean one out really thoroughly.
Yeah. For the baffles on the 1266, right? We have to run those once in a while.
Yeah, we
It's a
try to run all the
machine
steel
part.
together
Yeah.
because then we're back on aluminum.
So yeah, but other than that, yeah, I think that gives people an idea of why the hell we're using aluminum, because it's the best solution for what we're doing here.
Ticks the most boxes.
Yeah.
Well, with economies of scale, there's very little choice. Moving to something else isn't a little more; it's dramatically more expensive. And really, for our parts that aren't getting to 10,000 degrees, there's no advantage.
Yeah,
Typically,
we're not sending them to space.
Yeah.
you wouldn't use titanium for a low temperature application unless you had some sort of weird chemical interaction or you needed to be inert in some sort of weird environment or something like that.
I remember we did look to make one just for fun to make one titanium one, and not only was the raw material so expensive, but we would have to change the program because it couldn't run the same feeds and speeds, obviously,
And the
and it
tooling.
would have taken too long just to make one, and the cost was so high
It'd probably
that it just
shoot
didn't
through
make
a set
sense.
of tools for every part,
Yeah, well, that's the problem.
or a few parts.
Yeah, making that frame out of titanium would pretty much be like the cost of the headphone right there. It would be, it's insanity.
Yeah,
I
I
looked
think-
into it.
Wasn't it like
Yeah.
$500 for like
the
just
material
that?
is crazy expensive.
them?
Very,
Really?
very
Yeah,
expensive.
something
Yeah,
like
it's
that.
several $100s.
Yeah, some of the
last I
thicknesses
looked.
we need, you probably can't even get.
Well, that's the other
Well,
problem.
easily.
Yeah.
No, it's mostly custom,
Yeah.
Right.
but
that
in
was the
aluminum,
problem.
it's all stock.
Yeah.
Yeah. So yeah, that's why we use aluminum. It's that easy, in a nutshell.
I wouldn't say it's easy, but out of the available options, it's practical.
Yeah.
Yep.
Yeah, it's possible. And it results in a part that is superior than almost anything else, while still being like a feasible part to manufacture. It's not a $100,000 part or something. It's not a rocket part.
Well, that one we have an intimate understanding of how aluminum sounds, so we can adjust accordingly. We understand the sound of the reflections off of the material, how it resonates, and we've learned to compensate and adjust everything for that. The drivers, the tuning, the way that you shape the product, everything. We understand it, like, just like knowing how water comes out of a faucet, you can understand it. What's going to happen after that.
I know
So-
Ferrari's like that. They use a lot of aluminum in their cars, and everybody's like, "Why aren't you using carbon fiber?" And they're like, "Well, we know a lot of different alloys, and they have like 30 different alloys per car in
Yeah.
each different spot and everything."
Right,
They're like, "It's what we know,
right.
so we use it."
Yeah, you just get used to it. It's kind of be the same as cooking with certain ingredients versus not
Well,
using
yeah.
something else. You know how to make things. It's same with components and amplifiers. The higher end guys know what how a particular transistor type will act, bias different ways, and they adjust that accordingly. And they'll work with those transistors until you can't get them anymore.
And then they'll buy as many of them as they can
Yeah,
before
like-
they go out.
Yeah, and it's simply because they have a unique understanding of that part, and to do that all over again is a lot of work, right? You're learning it's a whole new learning curve every time you change parts. So, and that would be the same here. If you change materials, everything changes around it. It's not just the material; it's everything. The machining processes, the assembly processes, the finishing processes. Change is sometimes good, but not in manufacturing.
Right. Well,
Well, it's very difficult.
Yeah.
And
Takes
as a
time.
result, usually you don't produce a part that's as good as your mature prior process. Right? There's some merit to having a process that is very, very mature. You know the ins and outs. You can make very consistent, reliable parts, and you know how to push it right to the limit. But a new process, there's a lot of things that are uncertain. You got to figure things out. So
What-
usually you don't make as good of a part.
I guess doing it the first time with aluminum, we knew right in the beginning when we were trying to make just one set of titanium ones. It's like, this is not going to make sense. We knew to stop before we even started. It's like,
Well, you start
this
looking
is
at the
not
numbers
worth
and
it.
ooh.
This is not worth it.
Yeah, I wanted to do stainless steel and
Yeah.
nickel bronze, but the costs are just
It's
crazy
the time,
high.
We'd have you'd have to work on it all day on one machine. That would be down. It's like,
Yeah.
it's not worth
Yeah,
it.
they have to
It's
machine it so
staggering.
slowly
Yeah.
because the material's so hard to
Yeah.
cut through.
Right. That's why usually as a consumer, if you see something made out of something that they claim to be an exotic alloy, either it's designed in a way that it's machinable or manufacturable, designed out of round stock or something like that and run on a lathe and it's a simple operation, or it more or less is a veneer to make it look like titanium. It's like there's some sort of underlying structure and they coat it in something or they cover
You're
it in
not doing a
something.
lot of machine processes
It's not
to the part.
right. It's not a heavily machined 3D surface part or something like that because that would be just a staggering cost for a
Scissors are
consumer
a big
product.
one on that.
Yeah.
Like the low end scissors, they all say titanium. If you notice, all scissors say titanium on
Yeah.
them, but they're not obviously not titanium. They just got a coating.
What is that? A vapor? They just put a. Don't they just
I would
vapor
assume
deposit? I think.
it would be
Yeah, probably.
PVD or
Yeah.
something like
I
that.
think. Yeah. Just to make it a little wears slower.
CVD or PVD, I would imagine,
Yeah.
but it's just a thin coating on the outside. And unfortunately, consumers are kind of sort of convinced into thinking that things are made out of what they say, but it's a little misleading. There's a lot of that where they say it's some exotic
Yeah, right.
material, but it's like a coating,
Yeah.
right? Like a gold plating on something
That
could be
may
pennies.
not even matter.
Yeah,
to the overall
a lot of times
performance.
it doesn't actually enhance performance. Sometimes it
Yeah.
does.
I always wondered about drill bits. You know, I mean, there's definitely a difference between
People have tested it.
shitty
Oh, no,
drill bits and
That's-
stuff. But
There's a big difference.
Yeah.
Depends on the material you're drilling.
It's the
Yeah.
material, yeah.
Usually in like a drill press, it doesn't
Yeah.
matter.
Yeah.
The average person is going to roast the drill so fast before the thing
Too much
wears out,
pressure.
it won't matter.
yeah,
But
Too
in
high
some
speed.
materials, it makes a big difference. The coatings can be a world of difference
yeah.
Yeah.
sometimes.
Well, yeah. If you ever drilled stainless steel plate, you know how much
I hate drilling stainless.
how much the drill
On it-
matters.
in any way, shape,
Yeah.
or form, press or by hand.
Yep.
Yeah, stainless sucks.
It's not forgiving.
Yeah.
Well, and as soon as you start realizing, oh, I think this drill bit's roasted, it's already too late. It's
Yeah.
like, I think it might, nope, it's gone.
Yeah.
It won't cut
Yeah,
anything.
Like I said, I have a few videos back. I ran into that with cutting concrete board.
Oh.
That's some amazingly that makes tools hot real fast.
Yeah, carbon fiber is
That's
like
not
that
a
too.
high speed cut on that stuff.
Yeah.
That stuff will learn you about speed and cutting when on certain materials. You got to slow way down.
Yeah. Well,
Like
most people just hammer it
hacksaw.
and go for it. Mhm.
Yeah.
Yeah.
Yeah. Pushing doesn't help. in
Yeah,
this
You'll get
case.
by in wood, but
Yeah, that
not in
doesn't
some
work.
materials.
Yeah.
Yeah. So anyway, that's the reason why we use aluminum. Okay, everyone. Thank you for watching. And Christmas is coming, so remember that people are going to need headphones for Christmas. So order soon because we're going to run out before Christmas.
Yeah, you might want to get on it.
Yeah, it's getting already kind of late.
Mhm.
And so, yeah, that's at abyssheadphones.com. Or you could go cheap and just get some pillows and stuff at some of our pillows at abyssstore.com. Yeah. But in any case, thank you, everybody, for watching. Take care.